welcome back. In this video, we're going to continue with shortcuts for the derivative and see how they apply for finding equations of tangent lines. In this example, we're asked to find the equation of a tangent line for f of x equals 2x squared plus 4x plus 1 at x equals 2. What we would have done previously is we would have used the definition of the derivative, f of x plus h minus f of x over h, with the limit as h approaches 0 in front. Then we would have subbed in x equals 2 into that derivative to find the slope of the tangent line, and then put that ingredient together with other information to find the equation of the line. But we don't have to do that here. We can use a shortcut to find the derivative. I'm getting a little bit ahead of myself. Equation of a tangent line. We've got to make sure we're doing what we're asked. When you see a question, don't just take the derivative of whatever's there, or take a limit or evaluate whatever's there. Read the instructions carefully. Make sure you're doing what you're supposed to be doing. If all you did was you found f prime, and this is a 3 or 4 mark question, then you earned yourself either half a mark or 1 mark. You have to do the whole thing. So finding the equation of the tangent line means you're going to have y minus y1 is equal to m times x minus x1. You have to have all the stuff to plug in here. Now, one of these items is free. That's the x coordinate of interest, which we'll use for x1. What we don't have for free is we don't have m, the slope, and we don't have y1, the y value of the function at the target x value. So we'll get those. Put those next. y1 is equal to f of 2. So 2 times 2 squared plus 4 times 2 plus 1. We get 8 plus 8 plus 1. We get 17. So I'll put that there. And now we need m. We need the slope. M equals f prime evaluated at 2. F of x is 2x squared plus 4x plus 1. We'll use the derivative shortcuts to find f prime. 4x plus 4 plus 0. And then we'll plug in the x coordinate of interest, f prime of 2. It's going to be 4 times 2 plus 4, which is 8 plus 4, which is 12. And that is our answer. We plugged in that data into the expression for the line. Now this is the back of the book, or other things that some students are using to learn. It may be written in a different way. Y minus 17 is equal to 12x minus 24. So y is equal to 12x minus 24 plus 17. So y is equal to 12x minus 7. They're both good formats. Oh, it's making lines instead of going. Hold on. All right, this question has 3 parts. We're given a function x squared minus 10x, and we're asked first to find the derivative, then to find the point where the tangent line is horizontal, and then to find the rate of change of the function at this point. Oh, and there's a typo. What is the instantaneous? That needs to be there. What is the instantaneous rate of change of f of x at this point? Typo. Okay, part A. F of x equals x squared minus 10x. That means f prime of x is equal to 2x minus 10. That's it. Powers come down, new power gets reduced by 1. For x, we get x to the power of 0 for the new power, and almost anything to the power of 0 is 1. Okay, part B. What is the point on f of x where the tangent line is horizontal? This needs to be unpacked. Where is the tangent line horizontal? What does that mean? Horizontal line has slope 0. Tangent line tangent line at x equals a comes from f prime of a. So that's the slope of the tangent line comes from f prime of a. So that means, thus, f prime of x equals 0 at this coordinate. So 2x minus 10 is equal to 0. That's the condition we need that's the condition we need to occur in order for the tangent line to be horizontal at some coordinate. I'm going to add 10 to both sides, so 2x is equal to 10, and then that means x is 10 over 2, which is 5. Now the question said, what is the point on f of x? So a point needs an xy coordinate. We'll get the y coordinate next. Y equals f of 5. So 25 minus 50 equals negative 25. Thus, point is 5 comma minus 25. Okay, and then there's one more part. It's actually not a calculation, it's an interpretation. What is the rate of change at this point? Well, the rate of change at this point is 0. Instantaneous rate of change is 0. So instantaneous rate of change is equal to the tangent line slope, which is 0. Okay, now a question from a test. This is a really ancient test, I think. If f of x is x squared minus x minus 20, find the slope of the tangent line to the graph of f of x at the point 1 comma negative 20. Slope of tangent line at x equals a comes from f prime of a. So for this function, f prime of x is 2x minus 1 minus 0. So 2x minus 1. We want to plug in a equals 1, the x coordinate of that point. Two times 1 minus 1, 2 minus 1, which is 1. So that's the answer, option A. Okay, part B, or another question actually. It's just a different question. That was A16, this is B3. Consider the function f of x is x to the 5 plus 5x. Find the derivative, so that part's nice. 5x to the 4 plus 5, using all of our shortcuts. Find the slope of the tangent line at 1 comma 6. So f prime of 1 is our slope m. So 5 times 1 to the 4 plus 5, which is 5 times 1 plus 5, which is 5 plus 5, which is 10. Well, that part's done. Then the last part is write an equation of a tangent line to the graph of y equals f of x at the point 1, 6. So y minus y1 equals m times x minus x1. We found m. And we were given x1 and y1. So 6, 1, 10. Y minus 6 is equal to 10 times x minus 1. And that's it. That's our answer. And I'll see you in the next video.